Hello friends, now let us solve the Dcet 2019 question paper, branch electrical and electronics. Paper code is EE and the version code is H. In that, first let us solve the questions on the subject elements of electrical engineering. Okay, electrical engineering subjects fall under part C of the question paper. Okay, in that the 88th question is the unit of absolute permittivity of dielectric material is. See the question, the unit of absolute permittivity of dielectric material is. See the options, option A farad per meter, option B farad meter, option C Newton per meter, option D joules per meter. Okay, what has he asked? The unit of absolute permittivity. Absolute permittivity means epsilon. Okay, epsilon naught actually. Okay, we have C, the capacitance is given by epsilon naught A by D, where C is the capacitance in farad and A is the area in meter square, D is the distance between the parallel plate capacitors in meter. But now what has he asked? To find epsilon naught's unit. Okay, so we can write it as epsilon naught equals to CD divided by A, right? So what's the unit of capacitance? It is farad. What's the unit of distance? It is meter. What's the unit of area? It is meter square. So now meter and meter will get cancels. We got farad per meter. Okay, the unit of absolute permittivity of a dielectric material is farad per meter. Option A is the right answer. Okay, let us move on to the next question. Question number 89. A coil of 200 turns is linked with 8 milliwebers when carrying a current of 10 amps. If the current is reversed in 0.05 seconds, find the EMF induced in the coil. See the options. Option A 16 volts, option B 32 volts, option C 64 volts, option D 48 volts. Okay, what has he asked? A coil of 200 turns. So number of turns is given. Number of turns equals to 200. And what is given? 5. 5 means flux. Flux is how much? 8 milliwebers. Okay. Carrying a current of 10 amps. So I equals to 10 amps. And what is given? T. Time is given. T equals to 0.05 seconds. Okay. Find the EMF induced in the coil. Okay. We know according to Faraday's second law of electromagnetic induction, E equals to what? E equals to N into d phi by dt. Okay. So flux is known, current is known, time is known, number of turns also known. So easily we can find the EMF or voltage. So here what has it told? If the current is reversed in 0.05 seconds. The current is reversed means flux also reverses, as you know. Okay, when the current reverses, flux also reverses its value like this. Okay, current is reversed, so flux is also reversed like this. So what we can write it as? So N equals to 200 into d phi means change in flux. Okay, change in flux is 8 milliwebers, 8 into 10 raised to minus 3 minus of minus. So this is the negative value. So 8 into 10 raised to minus 3 divided by dt. dt is the time. So this is the time. We can take it as dt, change in time. Okay, 0.05 seconds. So if we simplify this, what will you get? 200 into 8 minus of minus. Okay, 8 plus 8 into 10 raised to minus 3 divided by 0.05. So how much will you get? So this will be 200 into 16 into 10 raised to minus 3 divided by 0.05. Okay. So now we can write it as 200 into 16 into 10 raised to minus 3 divided by 5 into 10 raised to minus 2. Okay, so we can write it as, so I will write it over here. So 200 is written as 2 into 10 raised to 2 into 16 into 10 raised to minus 3 divided by 5 into 10 raised to minus 2 is there, it will come here 10 raised to 2. So now it will be 16 2s are 32, 32 into 10 raised to 4 into 10 raised to minus 3 divided by 5, right. So now it will be 32 into 4 minus 3 is 1, so 32 into 10 raised to 1 divided by 5. Okay, 32 into 10 is 320 divided by 5. 5 ones are 5. So finally how much we got? 64 volts. So option C, 64 volts is the right answer. So let us solve 87th question in the same question paper. A coil has a resistance of 100 ohm at 90 degrees Celsius. Okay, at 100 degrees Celsius resistance is increased to 101 ohm. The temperature coefficient of resistance of wire at 90 degrees Celsius. Okay, what and all has he given? He has given as the initial resistance, reference resistance equals to R0 equals to 100 ohm, and initial resistance T0 equals to 90 degree he has Celsius he has given, and resistance at 100 degrees Celsius resistance is increased to 101 ohm, means at 100 degrees Celsius means final temperature equals to 100 degrees Celsius, the resistance is increased to final value. We can take it as RF also, I can take it as RT also, that is as 101 ohms. What has he asked? The temperature coefficient of a resistance of a wire at 90 degrees Celsius is. So we have the formula RT equals to R0 into 1 plus alpha of T final minus T initial. Okay, this is the equation for RT, the final resistance of the wire. So what we need to find? We need to find alpha, right? So I will simplify this equation. So RT is at the LHS side, R0 is at the right hand side. So RT divided by R0 equals to, I will write it as 1 plus alpha of TF minus T0. Okay. So RT divided by R0, here plus 1 is there, if it comes here it will be RT by R0 minus 1 equals to alpha of TF minus T0, right. So now it will be, take the LCM, RT minus R0 divided by R0 equals to what? Alpha of TF minus T0, right. So now what we need? Alpha we need, so I will write alpha at the LHS side and remaining things I will write at the RHS side. Alpha equals to RT minus R0 divided by R0, here it was alpha into TF minus T0 was there. If it comes this side, it will become TF minus T0. So this is the final equation for alpha, temperature coefficient of a resistance. So I will substitute the values. RT is how much? RT is 101 ohm. So R0 is 100 ohm divided by again R0 is 100 ohm into what is the final temperature TF? 100 minus initial temperature 90. So this will become 1 divided by 100 into 100 minus 90 is 10. So this will be 1 divided by 100 into 10 is 1000 So 1 divided by 1000 means 10 raised to minus 3. So 10 raised to minus 3 means 0.001. So everything, so that implies alpha equals to how much? 0.001. So which option is the right? Option B, 0.001 is the right answer. Now let us see the question number 90 in the same question paper. Two parallel plate capacitors have plates of equal area and different relative permittivity and spacing between plates. If epsilon R1 by epsilon R2 is 2 and D1 by D2 is 0.5, the ratio of their capacitances C1 by C2 is option A 2, option B 6, option C 8, option D 4. Okay, first understand the question. What has he given? Two parallel plate capacitors are there. Okay, they have equal area. Area is same means A1 equals to A2. Okay, and relative permittivity and different relative permittivity and spacing between plates. They have different relative permittivities and different spacing in between them. Okay, so he has given epsilon R1 by epsilon R2 is 2 and D1 by D2 is 0.5. What we need to find? We need to find capacitances ratio. Okay, C1 by C2. As we know the equation for capacitance of a parallel plate capacitor, C equals to epsilon A divided by D. Okay, he has mentioned relative permittivity, so I will take it as epsilon R. Okay, now area is same. Okay, so now what can I take? I will take it as C1, and similarly for C2 is epsilon R2 A2 divided by D2. I will take it as D1, I will take it as A1, and here C2 equals to epsilon R2 A2 by D2, C1 equals to epsilon R1 A1 divided by D1. So since area are same, I will take it as C1 is directly proportional to epsilon R1 by D1 and C2 is directly proportional to epsilon R2 divided by D2. Okay, what has he asked? The ratio of their capacitances C1 by C2 is. Now I will divide this by this. Okay, we will get the answer. C1 by C2 equals to epsilon R1 D1 whole divided by epsilon R2 divided by D2, right? So now this can be written as epsilon R1 by epsilon R2 into, so this is in the denominator, so this will be reverse like this, D2 divided by D1, right? So now it will be, he has given as epsilon R1 divided by epsilon R2 is 2, right? Epsilon R1 divided by epsilon R2 is 2 into D2 by D1. He has given D1 by D2. What will be he has given D1 by D2 is 0.5. What will be D2 by D1? Okay, here he has given D1 by D2 as 0.5. So that implies D2 by D1 will be 1 divided by 0.5, right? How much? 1 divided by 0.5 means 2 again. So this will be 2, right? So 2 into 2 is 4. So what is the answer? The ratio of their capacitance C1 by C2 is 4. Which option is right? Option D, 4 is the right answer. Okay, moving on to the question number 91. A 100 watt bulb burns an average of 10 hours a day. The energy consumed by bulb for 10 days is option A 10 units, option B 15 units, option C 100 units, option D 20 units. What has he asked? A 100 watt bulb burns an average of 10 hours a day. 100 watt bulb means power. Power he has given. Power is 100 watts. Right? Burns an average of 10 hours a day. Okay? So time equals to the energy consumed by bulb for 10 days. Okay, for 1 day it will burn 10 hours. Energy consumed in 10 days he has asked. So what is the total time now? So time equals to 10 days into 10 hours, right? It will be equals to 100 hours. Okay, energy we need to find. What is energy? Energy equals to power into time, because what is power? Power equals to work done per unit time. So work done is equals to energy. Okay, so according to this equation I have written as E as P into T. P is the power, T is the time, E is the energy. So that implies power he has given 100 watts and time is, we have calculated here, it is 100 hours, right? How much it will be? So 100 into 100 is 10,000 watt hours. But in the option he has given as units. Okay, so we can write this as 10 in 10 kilo, 10,000 means 10 kilo watt hours. So 1 unit equals to 1 kilowatt hour. So 10 kilowatt hour is equals to how much? 10 units, right? So energy consumed for 10 days burning 10 hours a day is given by 10 units. Option A, 10 units is the right answer. So let us move on to the next question. Question number 92. The reluctance of magnetic current is given by option A, mu naught mu r L divided by A. Option B, L divided by mu naught mu r A. Option C, L mu naught divided by mu r into A. Option D, A divided by mu naught mu r into L. Okay, what is reluctance? Reluctance is analogous to resistance. In electrical circuits we will call it resistance, but in magnetic circuits we will call it as reluctance. Okay, so reluctance is analogous to resistance. Okay, so reluctance is given by S equals to mmf divided by phi. Similarly, resistance can be given as R equals to EMF or voltage, EMF divided by current. Okay, so this can be also be given as Ni divided by phi. Ampere turn is also same, mmf is also same. So ampere turn nothing but magnetomotive force. So I have written it as Ni by phi. So we also have another equation, that is mu L divided by A. Okay, mu L divided by A. So L is the length of the coil, A is the area of cross section of the conductor. So this can be written as mu naught mu r L divided by A. Okay, so which option is right? Option number B, sorry, L divided by, sorry, so this can be given by L divided by mu into A. So this can be written as L divided by mu naught mu r into A. So option B, mu naught mu r divided by, sorry, L divided by mu naught mu r into A is the right answer. Okay, now the question number 95. Find the current through the 5 ohm resistor. So circuit he has given. Here the source is 16 volts DC, 3 ohm resistor is there, 5 ohm resistor is there, 2 ohm resistors, 8 ohm, 3 ohm, 4 ohm, 6 ohm. The circuit is like this. What we need to find? Current through the 5 ohm resistor. Which is the resistor? This is the resistor. So we need to find the current through this 5 ohm resistors. Okay, so for solving any circuits we need to check the short circuit first. Okay, because current chooses the lowest resistance path. Okay, so where is a short circuit, current flows there. Okay, if resistor is there, it won't flow there. See here, so the current from the source comes like this. here some voltage will drop. So current again comes here. Current, see, at this junction, three paths are, one path is this one path is this one, another path is this one. So where the current flows? Current flows in the lowest resistance path. The resistance over here is 0 because it is a short circuit. Okay, current doesn't flow in these two branches, so we can just cancel them out, right? Current doesn't flow here, current doesn't flow here. Where will it go? It flows in the shortest resistance path. So we can omit these two resistances. Okay. Next, after reaching this point, this junction, see the short circuit and the resistive path. So here is a short circuit, here are the resistances. So current chooses this path. So this path, these two paths can be omitted, right? So this is the simplified circuit right now. So what has he asked? Current through the 5 ohm resistance. So current comes from here, come from the source through this 3 ohm resistor, and this path and this path and this path, and current comes through the 5 ohm resistance. So that current we need to find. So we can simplify this circuit as, so since these two are in series, okay, since these two are in series, we can just add them. So total resistance is 3 plus 5 ohm. Okay, 3 plus 5 nothing but 8 ohm, right? So R equals to 8 ohm. Voltage is given, total resistance is given. We can find the current flowing in this circuit, right? So I equal to what? According to Ohm's law, I equals to V divided by R. Voltage is how much? 16 volts. Current is, resistance is how much? 8 ohms. So 8 ones are 8 twos are. So that implies current equals to how much? 2 amps. So total current flowing in the circuit is 2 amps. This is 2 amps. So what we found here? Total current we have found. But what has he asked? Current through the 5 ohm resistors. Since 3 ohm and 5 ohm are in series, whatever the current flows in the 3 ohm resistor, same current flows through the 5 ohm resistance. Since they are in series circuit, current will be same. So the current flowing through the 5 ohm resistor is also 2 amps. So which option is right over here? Option B, 2 amps is the right answer.